important to look at how the height of the system impacts the size of the expansion tank. And it turns out that the relief valve setting and the height of the system are interrelated, and they can have a big, how this gets laid out can have a big impact on the tank size. So let's look at another example here that will show you what can happen there as elevations change. So what I'm going to do here is I'm going to increase the height of the system here from 23.1 to 46.2 feet. So I've essentially doubled the height of it. Now, what I haven't done is I haven't changed this relief valve here. So if I go in here and I do my calculations, P-min is going to change. Instead of being 23.1, it's going to be 46.2. That means that now this is 20, and this guy becomes 39.7, and that means this is now 40. So if we go plug this into our formula over here, what we end up with is 27.5 on the top like we had before, but we end up with 1 over 40, which is P-min, over 40, which is P-max. That is a bit of a problem because now the bottom of the equation just went to 0, and that means we need an infinitely large expansion tank to handle this system, an infinitely large air cushion, essentially. So what's going on here? Well, essentially what's happened is that just getting my system full and up to pressure has literally got my relief valve on the verge of blowing. All right? So it turns out that the relationship between P-min and P-max really drives the expansion tank size in a huge way. As those two pressures get really close to each other, essentially making this number get smaller and smaller and smaller, it drives the size of the tank to a huge size. So what we need to do is kind of have a rule of thumb for making sure that we don't end up in this scenario. And it comes down to selecting our relief valve. And typically what I say, the rule of thumb is that whatever your fill pressure is, you ought to try to select a relief valve that's about twice your fill pressure. So if you had a fill pressure, say of 25 psig, you might look at picking a relief valve that's 50 pounds. Now sometimes boilers are set up in such a way, or they're designed in such a way that they can't have any higher relief valve than 30 psig. That's typical for, say, cast iron sectional style boilers. Smaller residential boilers and larger commercial cast iron boilers would only have a 30-pound relief valve on them. So, but many of the newer designs, the stainless steel and the water tube style boilers, or even fire tube style steel or stainless steel boilers, they can have relief valves up to 125, 150 pounds. So normally this can be dealt with. But it's important to keep that in mind, that as those two pressures get very close to each other, the expansion tank is going to get very large.